We are learning more about the severe turbulence incident on a Singapore Airlines flight last week that killed one man and injured dozens of others. We've now learned it was probably caused by rapidly developing thunderstorms, but some researchers say we could see more incidents like this without any storms in the area. It's called clear air turbulence, and while that's not what happened on the Singapore Airlines flight, researchers say incidents like it could worsen because of climate change. Joining us now is Paul Williams, professor of atmospheric science in the Department of Meteorology at the University of Reading in the UK. Thank you so much for your time, Professor. First of all, let me ask you, before we go into a clear air turbulence, about these rapidly developing thunderstorms. I mean, obviously they develop so fast that pilots don't even have time to warn the passengers to put their seatbelts on.
That can happen with these thunderstorms. Of course, no one wants to fly through a thunderstorm, but actually even flying around a thunderstorm or near a thunderstorm when you're not physically in the storm itself, that can be turbulent too, because the storm can generate waves that propagate away from the storm. So you can be tens of kilometers away and still experience some pretty rough air.
And will we be seeing more rapidly developing thunderstorms because of climate change as well?
There has been one scientific study on that published recently, and it found that all forms of turbulence that affect aircraft, so that's the thunderstorm related, but also the clear air turbulence and flying over a mountain range, those are the three categories. They're all projected to strengthen in future in most regions around the world because of climate change.
So, when this first happened, when we saw the first images of the passengers getting off the Singapore Airlines flight with head injuries, spinal injuries, I mean, obviously it was very frightening to know that 10 hours into a flight when you're 37,000 feet in the air, that you could experience this kind of severe thrusting. And the speculation initially was, well, maybe this was clear air turbulence. First of all, tell us what that means. What is that?
Yeah, well, it must have been terrifying for those people on board. I think it must have felt like being on a roller coaster without any harness in place for those who weren't seatbelted. The clear air turbulence is invisible. It's got nothing to do with storms. It's actually generated by these fast air currents called jet streams, which if something called the wind shear in the jet stream is too strong, it can break down into this invisible turbulence, which does not show up on the radar in the flight deck. So it has the potential to be particularly problematic coming out of the blue when the seatbelt sign could well be switched off.
What was your reaction when you heard about this? I mean, I don't remember the last time I've heard of, people being taken to the hospital, having spinal surgeries or skull injuries because of turbulence on an airplane. Has something like this of this severity happened before?
Injuries are happening quite often. There are hundreds of injuries from turbulence annually around the world, most of them minor, but the most serious ones, as you suggest, for people who are in hospital for over 48 hours is the definition of an injury that requires mandatory reporting to the authorities. They're relatively rare, but they can happen. The last fatality that I'm aware of from turbulence happened back in 2009. And the one before that was from clear air turbulence in 1997. So fatalities, fortunately, are not happening every year. It's more like once in a decade or less. And I think we're all thankful for that.
So are you concerned about this clear air turbulence as somebody who presumably flies? I think you said that your latest future projections indicate a doubling or tripling of severe turbulence in the jet streams.
That's correct. We've been analyzing the numbers. The tricky thing about clear air turbulence is the fact that it's invisible, so it doesn't show up in satellites can't see it, for example. But what satellites can see is the shape and structure of the jet stream. And when we know that information, we can actually crunch some numbers and calculate how much clear air turbulence would have been there, even though the satellite itself can't see it. And when we crunch those numbers, we do find there's today 55% more severe turbulence over the North Atlantic than there was back when satellites first began observing it in the 1970s. And as you've said, the projections based on computer simulations of the atmosphere for the future are for a doubling, or in some parts of the jet stream, a trebling or even worse in the coming decades if the climate continues to change as we expect it to.
Yeah, well, that's concerning, and hopefully, we'll just continue to wear our seatbelts even when that seatbelt light comes off. Professor Paul Williams, thank you very much.